Hello, today I'm going to talk about how to use SVM in MATLAB and specifically using the fitcsvm function that is implemented. I don't know what version it was, but last time when I used the SVM, it was the train SVM or SVM train or something. But one day it changed into fitSVM, so we're going to use the how to use the fitSVM and fitcsvm and how they are like useful and convenient to use in MATLAB. So the procedure will be like this. First, I'm going to prepare the dataset and divide it into training and test set. And secondly, I'm going to prepare the validation set out of the training set, which is usually for the k-fold cross validation. And thirdly, I'm going to choose the features that are useful for the classification with the cross validation, and then I'm going to find the best hyperparameters that is best for the classification. These two, third and fourth will be in the procedure of the cross validation. And lastly, I'm going to test the model with the test set, and also I'm going to visualize the hyperplane that is made from the procedure through the procedure. Alright, this is my MATLAB window, and I'm going to be type the code through the procedure, and let's get started. From clear, close all, and CLC. And let's prepare the dataset. And I'm going to use the fisheriris dataset, which is basically given in the MATLAB. Like this is like a basic dataset, and like many people use it when you practice the classification. And as you know, this data set has 3 class labels, Setosa, versicolor, I don't know how to pronounce it, Virginica, I don't know. Anyways, so there are like 50, and 50 samples for each class, and there are for each sample there are 4 features for them. Okay, I'm going to use them, and then what I need to do is to change the string labels into numbers. As you can see here, they are the strings. The labels are strings, but the function that we are going to be used is the fitcsvm, and it does not understand when the label is in string, but it does understand when the label is in numbers. So what you have to do is to use this function to change the strings into the numbers, like this 1, 2, and 3, and let's name it species number. Okay, so far so good. And we are going to make this as a binary classification problem. So basically the SVM is a binary classifier, so I want to make it as a binary classification problem. So the features, choose the features data, choose the data from 1 to 100, and then we're going to get the labels, of course, from 1 to 100. So like as you can see, there are like 50 ones and 50 twos, and to make it like more like real, I'm going to add features that are useless. 6 useless features. So They are randomly made the 10 features for each the class for each sample, and 1, 3, 5, 7. If you run this, and you'll see that first and third and fifth and seventh feature will be useful for the classification, and then the others like 2, 4, 6, 8, and 9 and 10 will be useless for the classification. And we do this because I want to go through the feature selection procedure here, and then let's see if the feature selection procedure chooses the feature out of 1, 3, 5, or 7 or not. Okay, so what I've done so far is to prepare the dataset, and now we have to divide it into training and test set, right? So let's go. So xtrain will be, I don't know how to separate them, like make it into 80 and 20, and then let's this is how I usually do, and maybe some people do it differently. Randperm, and there are 100 data, and then you'll see, oh, what was wrong? Oh, randperm. So it like randomly permutates the integers from 1 up to 100, and I will use this to randomly get the data set random 1 up to 80, xtrain, 80 samples and 10 features, and ytrain is y and rand the same number. This, let's get the randomly chosen 1 or 2 the samples of the samples with the different labels, like they're really randomly chosen. And then test is a x random first 2 up to the end, and then choose all the features, and y test will be y rand number 81 up to end, like that. And you'll see there are 20 the samples extracted out of the y, the original y, and then we see that they are like randomly chosen. Okay, so what I have done so far, so this is the preparing data set and divide it into training and test set. Okay, so and then the procedure number 1 is done, and procedure number 2, let's get it done, and preparing the validation set out of the training set, and this is for the k-fold cross validation. And the MATLAB has given us a very useful function that's called cvpartition, and by giving such the input argument, we'll get kind of object that is for the cross validation afterward. So we have the 80 like training dataset, and it divided into 80% and 20%, and it made 5 of the set for the cross validation. Okay, so and then let's do the so the number 2 is done, the preparing the data set, the validation set out of the training set. This is really easy and well made in MATLAB. I love it. And let's do the feature selection part, and this is kind of like difficult, but you'll see, you'll get it. Like I'm going to use the sequential feature fs function, and it needs a function and the features and then the labels ytrain. Okay, this is how the sequential function works. And there are several options that we have to add. This is for the cross validation, and we use the C that we made last time, and then add some options. I'm going to make it later, and there are features that we can specify like this. I am going to extract only 2 features for the visualization, the procedure afterward, and yeah, you don't really have to choose only 2 features if you don't want. And maybe if you remove this option, and it'll it'll work until you get the validation accuracy, and then it stops, and then it gives you a specific, what I say, the combination of the features that are useful for the classification, of course, for the validation accuracy. So then the output arguments are like that, and as you can see, we have to make the function that we didn't make, and options, of course, function statset, and this is only for the display, so you can just memorize or copy and paste for that. And for function, this is kind of complicated, but you'll see. What it have to do is to predict with the model and a test set. And what it does is test data. Data is better word for it. And with this model, and it'll predict test data, and then it'll spit out the either 1 or 2. In my case, it's 1 or 2. It may be 0 and 1. It doesn't really matter, anyways. So it'll use the model and the test data, and it'll compare with the text labels, and it'll see how wrong the model was. So by summing the errors, and it'll give how wrong the prediction was. So, and then the model, we have to use the fitcsvm. It'll make a model using the SVM, and train data, and train labels, and KernelFunction as radial basis function. And let's make it with the inline function, labels, test data, test labels. Okay. Is this well made? Yeah, I think so. Let's make it. Let's run it here. Okay, it works. Okay, let's see how the feature selection works. So so it started the sequential feature selection, and then I used the forward one, and of course you can add more like options to make it backward. But in my case, I'm just going to use the forward one, so I don't want to use it. And then you'll see that there are the initial conditions included and columns that cannot be included, and you can specify them with some options that in such a like a situation like when you want to include some features that you really want to use for the classification, then you can specify it. And if you don't want such a features that if you don't want a feature not to be included in the classification, then you can specify them as well. And then as you can see here, it chose the column 5th and 1st as the useful features for the classification, and this function found that the 5th and 1st features are the best combination for the classification, as long as the number of features are 2. Okay, so this is the result fs. The 1st and 5th column, I mean the 1st and 5th, the element of the logical array is 1 and the others are 0. And struct history, you go to see how they are chosen here, history. Like the first time it chose 5, and the second time it chose 1 and 5 as the best combination of the features that are useful. Okay, so what we have done so far, from 1, 2, and 3, we did the feature selection as well, and we're going to be finding the best hyperparameters for the classification. Okay, hyperparameters, and you see that we have chosen some hyperparameters that are the features that are useful for the training, from the cross validation, and then we just want to use the features that are useful for the classification. And yeah, this is what you get if you use only the features that are useful. Okay, and let's get the hyperparameters, and we're going to make a model that are model with the best hyperparameters, and you'll see CSVM. And train. This will make a model, as you know, and then make a kernel function as radial basis function, and there are lots of the options that are really complicated. So if you really want to use it, then you can copy it to notepad or something somewhere, and then paste it to use it. So hyper, and then hyperparameter optimization options. This is really crazy if you memorize all of them. Acquisition function name, and then the name is expected improvement plus, and I'm going to show the plots true. All right, let's see how it does. Hopefully it works. Oh yeah, and then it shows you how the so there are grids on the bottom here, and then you choose the C value and gamma value, and then it chooses the best the combination of the C and gamma, and then as you see there are the what do you call these lines, the lines, and then you see the objective functions and how it looks, and how the loss becomes as you make the more evaluation for the C and gamma value. Anyways, so it made you it gave you a model with the best hyperparameter, and you see here the model one. And you can see the C values here, and the gamma values here. Where are you? Okay, the gamma value and then the C value here, this shows that this model has the best hyperparameters for the classification. And yeah, let's see how it works if we apply the training, the test procedure. Let's see, we did so far here and test the model with the test set. Okay, test. So the test dataset with best feature. So these features are chosen from the cross validation, right? And then we're going to predict with the model that we made, and let's see how it works. Okay, so the computer gave me the 1 1 1 2 2 and like that 1 2 1 1 2, something like that, and this is how the computer thinks with the model and with the features that you gave me. And then I think the label should be like this, and the real label is what was the label? Oh, the Y test. Sorry, Y test. So this is a real label, and you can see how correct they are using the two equal signs. And let's see. So it got all right, and 21s. And then if you sum it, and then divide it with the length of the Y test and times 100, it'll give you the length. It'll give you 100% for the predict test accuracy and accuracy. You can save it like that. And this is all about the SVM, how to use the SVM with the fitcsvm function. And I'm going to show you the hyperplane in the model. So this is the code I just copied from another code that I worked earlier, and you'll see. So this is the feature, the dimension, the first dimension, maybe the fifth, and then the first, maybe the feature out of the 100. The 10 features for the X here. Train, yeah, the train set. So the first one shows I don't know the name of the label. Anyway, the first and the second, the class, the labels, and this is how they look like in the feature dimension. And then you'll see using the model, and then it chose such data set as the support vectors. And if we make the hyperplane in between these, the support vectors, and it'll be like a good hyperplane for the classification. And you'll see the axis here, the red axis are the samples that are for the first class labels, and these axes are the second the samples for the second class labels. And you'll see if we make the hyperparameter here, and then it'll give you it'll make a like a really good prediction for the test labels. And you see that the decision the plane. If you draw it, you see the hyperplanes are made here, and you see that if we put the test set here, the X, and then it shows how perfectly made a hyperplane to separate to classify the test set here. Alright, so this is it, and I'm going to put the MATLAB code that I used under the description, and hope you like it, and thank you.